All right, guys. So in my previous video, I built this infrastructure out, this simple network infrastructure, which is quite frankly oftentimes a basic backbone to enterprise medium companies. Here you have an end user that can ultimately ping 164.100.100.2, which is supposed to signify an outside network or the internet, right? So come on, let's go ahead. Come on, ping. Yeah, so it works, right? We can get from one point A to point B. Now, and again, if you want to know how to build this infrastructure and need some explanation, I went ahead and created other videos previous to this, so go ahead and watch it. But in this video, I want to focus on a protocol called OSPF. Now, the reason why I want to add OSPF is because right now what we have in this scenario is that yes, this end user can reach this server. It works, okay? But the only reason why it works is because right now this internet router learns this destination through the direct connect, right? So if you look at if you go ahead and look at the route right here, the reason why it learns 164.100.100.2 is because it's directly connected. And oftentimes you don't have a scenario that has a network like this, right? Or as simple as this. And so that's why I want to that's why we use routing protocols to route traffic to a destination that's further away and that has multiple hops and has to go through multiple networks, right? And so in this video, I want to go ahead and go through basic configuration and basic understanding of OSPF, or rather Open Shortest Path First Protocol, okay? So OSPF, smiley face. Okay, so let's see. Let me go ahead and move this to the side. And let me go ahead and write down a couple of things that you need to know. You need to know what hello packets are. In OSPF protocol, there are 5 different packets generally that are sent to neighbors. Okay, I want to just talk about one, the first one, hello packet. Essentially, what hello packets do is it identifies neighbors and essentially, it serves as a keep alive, right? And it also is there to elect designated routers or backup designated routers. But again, in this video, we want to keep things very simple. I'll definitely build upon the concept of hello packets and hello protocols as we progress through the videos. But for now, just know that there is something called hello packets, okay? Couple of commands to enable OSPF. How do you enable OSPF? So commands, let me just do OSPF. Commands include router OSPF and a process ID number. Let's just say 1. Process ID numbers do not matter in OSPF. Each different router can have different process IDs, okay? What we want to also do is have network commands. So you'll have, this will make more sense as I go through it. And then you have your wildcard. Yeah, so there you go. Wildcard and the area. We're just going to do one area, area 0, which is the backbone area. Again, trying to keep things very simple. And then ultimately we need the router ID to identify what routers what. Show IP route to show the routes, the advertised routes in the routing table. Show IP OSPF neighbor or data, neighbor to see its OSPF neighbors, and then show IP OSPF database to see how the database is being built. Okay. So again, we're trying to keep things very simple as possible. Now to finally build it, let's start with designing it first. Here, let's go ahead and break this link. Let's move this network here. again, this at this point, this end user cannot obviously ping .2 because there's nothing connected, but this end user can ping every endpoint here. Okay. I want to change this to a /24 because later on I want to scale it. You know, I want to have a router here and build another network out here. Let's see. Let's do this. And okay, so we have this. How many routers should we have in between, or how many networks should should the hop take to get to the final destination? Let's add 3 routers. 3 sounds great. I'm going to use 2911 just because by default it has 3 available gig interfaces. Okay, I'm going to call this internet router. Okay, fine. Should we call this router 1? Internet router 1. Let's do that rather. And then router 2, 3, 4. All right. So label. Now let's get some IPs going out. So actually, should we do this? Let's do 140. The reason why is because router 4, 140. I don't know. Does that make a little bit things a little better, more organized maybe? I guess I could do 4.4.4.4 or something like that, but let's just keep it this way. It looks semi real. All right, so 1 and then 130, 10. Here, let's do this. So 130, 100, 100.0/24 network. Again, I use 24 because it is very simple. 100.1 being the first endpoint. And then 130.100.100.2 is the endpoint. And then 120. Let's do 120.100.0/24 here. 120.100.100.1 here. 120.100.100. Whoops. 100.2 here. All right, and then 110. 24. Oh, that's a very funny looking IP address. Actually, all of them look funny. I guess it's funny depending on where you live in the world. 100. Okay. 102. Okay, now configuring everything. Let's do 01, 0, 01, 01, 02, 02. But then, yeah, I tried to keep things organized as possible. So 02. Okay, so they're all connected. Now all I need to do is add IP address to each endpoint. Okay, so show run. I think we already had 01 configured from previous lesson. Yeah, so what we're gonna do is configure T int gig01 IP address 110.100.1/24 no shut and show run. Okay, cool. Nope. And let's do let's host name or gig01 IP address 110.100.100.2. Give it the subnet mask, no shut. Now let's end. Let's see if I can reach from here to here. So ping 110. Come on, come on, come on. Yeah, so it's fine. This is fine. Now let's configure conft int gig02 120 100. What am I doing? IP address 120.100.1/24. No shut. Okay, and No. Hostname router 3 int gig 02. Now let's see if I can ping the other end. 100.1 should be good. All right. So we have that and that. Okay. Okay. So now gig 0 and gig 01 IP address 130.100.100.1. No shot and. Nope. And conct hostname router 3 IP address 131.100.2/24. Of course, I didn't have an interface selected. Interface gig 01. Wait, am I on router 3? Yes. Int gig 01 IP address 131.100.100. Wait, I'm confused. Where am I? Oh, I'm on router 4. Wow, see? You know, if you did this in production, well, you wouldn't do this in production. Well, would you? You wouldn't change hostname in production. Router 4, interface gig 01, and 130.100.100. No shot. There we go. Man, little mistakes like that can just mess you up, you know? That's why designing this and carving out your IP scheme and thinking about it in advance is so important, especially if you do this in production, because little mistakes could actually end up being very costly. IP address, nope. Int gig 02, IP address 141. Okay, no shot. And now let's give this guy. Did we do this? No. Let's 40.2 default gateway the next hop, which is here. Okay, it's 140.100.100.2. So we can ping this way. Ping 130.100.100.1. So all these interconnects can ping each other. They can ping each other. The real issue here now is, okay, that's fine. Tell me how I can ping the final destination. All right, it can't. It doesn't know. The traffic will stop here. It just doesn't know how to take traffic sourcing from here and going all the way here again without a routing protocol. There's no way. As the only the furthest destination this end PC can ping is 100.2. Where's my marker? Not sure why I didn't learn that too. 110. Let's see. Show. Right. Show IP route. Right. Yeah. So we can ping dot 1. Not sure why I can't hit 2. It's learning. Oh, you know what? Because it doesn't have. Okay, the reason why. Okay, so the reason why after point 2,